Hello everyone, welcome back to logicbinder. In this video we shall discuss about how to eliminate left recursion and how to perform left factoring. The first feature which is not desirable for top-down parsers is ambiguity. Similarly, another feature which is not desirable for top-down parsers is left recursion. What do you mean by left recursion? A grammar is said to be left recursive if it has a non-terminal symbol A such that A derives a string beginning with A itself. In simple terms, if the production can be rewritten in the form A goes to A alpha, where alpha is any sequence of terminals and non-terminals, then that grammar is said to be recursive grammar. For example, something like this: B is a non-terminal, B goes to BB. Okay, or you can include some other non-terminal also, some D goes to some epsilon, like this. Means if it is B is appearing on the right hand side at the leftmost position and followed by alpha. Alpha could be, here alpha is BAD. BAD, it is a combination of terminals and non-terminals, like that. Then it is called as left recursion. Top-down parsers, especially LL1 parsers, cannot handle left recursive grammars because they may enter into an infinite loop while parsing. Therefore, we need left recursion to be eliminated before constructing the parser. The general form of left recursion is this: A goes to A alpha or beta. Here A alpha is left recursive part and beta is non-left recursive alternative. Or means A goes to A alpha or A goes to beta. There are two productions in which one is left recursive, one is not left recursive. To eliminate this left recursion, we will introduce a new non-terminal A dash and rewrite the grammar like this: A goes to beta add A dash goes to alpha A dash or epsilon. Epsilon is nothing but a empty string. This transformation removes left recursion while preserving the language generated by the grammar. As a result, the grammar becomes suitable for top-down parsing techniques such as LL1 parsing. We shall see an example how to remove left recursion when a grammar is left recursive. See here in this, E goes to E plus T. Here left recursion is there, and also here T goes to T star F. Now I am taking E goes to E plus T or T. Compare it with this one: A goes to A alpha or beta. Here in place of A you are having E, here also in place of you are having E, in place of alpha you are having plus T, in place of beta you are having T. How to convert it? You have to take this. What is A? E. A goes to beta add A dash. What is beta? T. In place of A dash I can take E dash. Now A dash goes to means E dash goes to alpha means plus T, A dash means E dash or epsilon. This has been converted to non-recursive format. Next recursion is left recursion is there here. Let me take that one also. T goes to T star F or F. Compare it with A goes to A alpha or beta. In place of A you are having T, in place of alpha you are having star F, in place of beta you are having F. Again I am constructing this one: A goes to beta A dash. A means T, beta means F, A dash means I can take it as T dash. Again A dash means T dash goes to alpha. What is alpha? Star F. A dash means again T dash or epsilon. Means these two have been considered as left recursion and the left recursion is removed. The final grammar will be like this: E goes to T dash, E dash goes to plus T dash or epsilon. Next this T goes to FT dash, T goes to T dash goes to star FT dash or epsilon, and there will be no change in last productions as there is no left recursion. This is the final converted grammar after removing left recursion. Now let us see what do you mean by left factoring. For top-down parsers like LL1 parser, the grammar should be free from ambiguity and left recursion. Another important requirement is left factoring. Left factoring is the process of rewriting a grammar when two or more productions of a non-terminal begin with the same prefix. Since a top-down parser makes decisions based on the next input symbol, common prefixes can create confusion. Left factoring removes this problem by factoring out the common prefix. Suppose we have these productions, A goes to alpha A1 or alpha A2 or alpha A3 and so on, alpha N or beta. Here the productions, all these productions alpha A1, alpha A2 and so on, alpha AN have common prefix alpha. All are starting with alpha. After performing left factoring, means we will take alpha common, and we are placing A dash in place of A1, A2, AN and so on to AN. See here, A goes to alpha A dash. In beta you are not having alpha, it will be as it is, means A goes to beta will be as it is. What is changing? A1, A2, A3, AN, all in this place of I am taking A dash. This is how to convert left fact. See here we have taken some productions where there are common prefixes. See, alpha is the common prefixes in these productions and beta is not having alpha, means there will be no change in A goes to beta. A goes to beta will be as it is. What will change? We will take alpha common. I have taken alpha common and all these A1 to AN are taken as A dash. This is how to perform left factoring. See this example, V goes to AB or AC or D, where I am having common factors in this and in this. No need to change D. V goes to D will be as it is. What I have to take common? A. If I take common A, what I will get? B or C. That one I am naming as V dash and placing here. V goes to A V dash or D, V dash goes to B or C. Another example. See here, A goes to plus T or plus V or plus M or C. T goes to A or B, V goes to D. In these two productions, I don't have any left factors, left common factors. In this production I am having, for A I am having, that too plus is the common prefix. If I take plus as common and consider T, V, M as A dash, what I will get? Plus A dash. And A goes to C is not having any common prefix. You have to write as it is, A goes to C, and write these productions as it is. This is the converted grammar after performing left factoring. This is how to do left recursion elimination and how to perform left factoring when a grammar is given. Thank you for watching.